Intro.
Topic is about salinity of the ocean. Okay, what is salinity? Salinity is the dissolved salt content of a body of water that is known that contributes significantly to the conductivity and aids in the determination of many aspects of natural water chemistry and biological processes. Okay, so salinity is not measured by weight because it is difficult and tedious to dry all the salts in the seawater. Salinity is more easily and routinely determined with a salinometer that measures electrical conductivity, which increases with increasing salt content. Major constituents of seawater with a salinity of 35. Okay, as you can see, chloride is 18.98 in concentration. Okay, mali ako. Okay, I'm gonna show you the major constituents of seawater. Here is the chloride, 18.98 by concentration, and by the percent of weight of all the salts in the sea is 55.04. In other hand, sodium is 10.56 in concentration, and by the percent of the weight it's 30.61. The sulfate is 2.65 in concentration, and the percent is 7.68. In magnesium, it's 1.27, and it is in the percentage of the weight, it's 3.69. Calcium is 0.40, and the percent is 1.16. Potassium is 0.38, and the percent is 1.10. Bicarbonate is 0.14. The percent is 0.41. Next is the bromide, which is 0.07, which is in the percent of the salts in the sea is only 0.19. Borate is 0.03 in the concentration and 0.07 in the percent. And the strontium is only 0.01, and the percent by weight is 0.04. Okay, so in this other figure, we're gonna show you the generalized schematic cross-section showing the main thermal layers of the ocean and their average temperature at the equator. Constituents in table 2.1 make up about 99.9% of all the dissolved substance in the ocean. The constituents that I have read to you, some of these, such as oxygen and water, are essential. Carbon dioxide and other dissolved gases are present and will be discussed later. Those elements connected to biological process, unlike the ions shown in the table, the concentration of the nitrate. Elements connected to the biological process are highly variable, stable despite the presence of dissolved organic molecules in salt water. The concentration of salt in water, that is salinity, is around 35 parts per thousand. In other words, dissolved salts account for around 3.5% of the weight of the seawater. The weight of salt as sodium chloride in a cubic mile of salt water is approximately 120 million tons. Most of the primary ingredients concentration aren't uniform. They are thought to be greatly impacted by biological and chemical interaction. Of the primary ingredients, concentration aren't uniform. There are thoughts to be greatly impacted by biological and chemical interaction. which behaves in a conservative manner. As a result of this feature, the consistency of the chemical makeup of seawater, that is, the total salinity may vary, but the relative salinity remains constant. As you can see there, the ratios of each major ion to the total of remain consistent, as do the proportions of each major ion to the total, and the ratio of each major ion's concentration to the others. These ionic ratios have changed. Only in a few isolated areas, such as estuaries, can it deviate from normal freshwater in flow with varying relatives quantities of main ions. Okay. Certain marine locations contain salinities that are higher than those seen in open ocean. Range and distribution of salinity. So the maximum salinity levels can be seen around 20 to 30 degrees. Okay, you can see there, 20 to 30 degrees. Latitude in both hemispheres. In evaporation-prone locations, a lack of precipitation. Polar locations which have high salinities have low salinities. Precipitation as well as melting ice and polar water affected places. This, which is given through roughly characterize particular types of marine environments. As you can see, fresh water has a salinity of less than 0.5. Brackish estuaries are 0.5 to 17. Black Sea is 16. Ocean range 32 to 37. And ocean average is 35. So the surface waters have significantly wider range of salinity than deeper seas. Seas vibration are mostly caused by sea surface atmosphere, and the salinity becomes higher as the depths go lower. Next is the biological importance of salinity. Okay. Salinity is important because it contributes significantly to conductivity and aids in the determination of many aspects of natural water chemistry and biological process. The physical qualities of water, such as density and heat capacity, are governed by salinity together with the temperature and pressure. The salt is present in most marine invertebrates. The importance of biological aspects of the ocean. Salinity is important for the biological aspects of the ocean because the salt is present in most marine invertebrates and primitive shark rays. Their blood contains bodily fluid that is similar to seawater. So there is a tendency for water to move across semi-permeable membranes from a zone of low salt concentration to one of high concentration, that is called osmosis. What is osmosis? So osmosis is a process in which solvent molecules tend to move through a semi-permeable membrane from less concentrated solution to a more concentrated one, bringing the concentration on both sides of the membrane to the same level. So the majority of marine fish, for example, expel extreme modest amounts of waste. Gills produce large amounts of urine and discharge salt. These forms of active participation. The kidneys work against the natural osmotic trend during transit. So the oscillation, and that is through the mouth and the gill membranes, they absorb a controlled amount of water. Because they drink so much water, they create a lot of urine, which causes them to use a lot of salt. With the help of mitochondria-rich cells in the gills, salt is replenished. As you can see here, this is a seawater fish. Seawater drinks a lot of water. Active ion transport through gills, concentration. It can also be gone by concentrated urine. And it also loses salt or water through its skin. Saline fishes, it is an aquatic organism able to tolerate a wide range of salinity that is, for example, stingray, bull sharks, green chromide, and mummy chalk. Next is the stenohaline, an aquatic organism that is able to tolerate only a narrow range of salinity, which is molly, goldfish, salmon, and eels. So that's all for today for this topic. Passing the floor to the next reporter.